often do you find a book that interprets the universe from a mathematician point of view, cancels the usual stereotype of mathematics being boring and pointing out real-life situations that lead us to a greater appreciation of the universe mathematically? This book is no other than Nature's Numbers by Ian Stewart.
In Chapter 6, Broken Symmetry, it is emphasized that nature has symmetries at every scale, from the smallest particles up to the galaxies. Mathematics describes how symmetries break to understand that the patterns we see in nature are limited to physical processes and mathematical phenomena.
Broken Symmetry is a collection of our daily life and is related to the context of mathematics. Symmetries are exact within the limits of present knowledge. There are situations where it is hidden or broken in some manners. It's no coincidence that our universe is naturally full of symmetry, just like how mirror symmetry reflects the external forms of many creatures, especially in us humans. Symmetry breaking is a simple, beautiful idea, yet justifiable and practical.
Mathematically, symmetry means that one shape becomes exactly like another when you move it in some way. Turn, flip, or side, or as Ian Stewart describes it, bilateral symmetry.
With that said, Stewart presented three common transformations, namely refraction, rotation, and transformation. All of them further explains symmetry. Reflections or flips are also known as bilateral symmetry or the mirror effect when one object is reflected across a plane to create another picture of itself.
On the other hand, rotational symmetries or turns, on the other hand, occurs when you get on the same image of an object when spun at 180 degrees. Relatively, translations are symmetries wherein an item is relocated to another position while maintaining its general or exact orientation. As Stewart states, it is the rule of moving things around.
Stewart also mentioned bland uniformities, telling us that nature's balance are so precise and extensive that every point it contains is highly equivalent to each other. When arranged in a specific order, it creates a series of patterns in it. These points look too unnoticeable that we fail to notice the presence of waves. The existence of patterns in natural existence is what make up symmetry.
Stewart further discussed to us the concept of broken symmetries, the main idea of this chapter. He visually explains this idea through using a pebble that is thrown into a pond.
The pond has several extensive points that we only see a flat body of water without seeing different patterns. When a pebble meets the surface of the pond, it loses its symmetrical look except for the point where the rock strikes. Altering the original state of the pond creates a pattern of concentric circles or ripples in the water.
Correspondingly, he used broken symmetries to unify what at first sight appeared to be very disparate phenomena. He emphasizes that through the symmetry breaking processes, we can explain in a unified way that the patterns we see in dunes and zebra stripes are physically different yet mathematically very similar.